Probability 3, calculating probability. So, like I said, in mathematics, we use numbers, and numbers are very important. So we're going to look at different ways of how to calculate the chances of something happening instead of guessing. The first type of calculation involves a yes or no, a on or off, a binary choice. Remember, we said that a probability of something being certain, being guaranteed, 100% is going to happen, is actually equal to 1. So if the question is, what is the probability of rain tomorrow? We are going to write an equation that says probability of rain plus the probability of no rain is equal to 1. Because either it's going to rain or it's not going to rain. There's no third option. It's a binary choice. So we're adding all of our probabilities together, and that equals to 1. So now the statement says probability of rain is 2 out of 3. So what's the chances of no rain? So we are going to replace rain, the word rain, with the statistic for rain. So probability of rain is 2 out of 3. We replace that, and then we have no rain equals that. We take this over and we solve. 1 minus 2 over 3 is 1/3. The probability of it not raining is 1/3, or 33.3%. Here's a question that says that a school basketball team plays 20 matches in a year. The probability that they win is 3 out of 5. What is the probability that they lose a match? So first thing we have, what are our two binary choices? We have the probability of a win plus the probability of a lose is going to be equal to 1. The probability that they win is actually 3 out of 5, plus the probability that they lose is going to be equal to 1. Question A is asking me what's the probability that they lose. So I'm going to take probability that they lose is going to be 1 minus 3 out of 5. Therefore, the probability that they lose is going to be 2 out of 5. Next question, how many matches can they expect to win each year? This is where that 20 comes into play. So how many can they expect to win? We will then say 3 out of 5 is our winning probability, as you can see, multiplied by 20 being the total possible options. That gives me 60 over 5, which is 12. So they are probably going to win 12 out of 20 matches for the year. The next question says, a child is chosen at random from a school. The probability that it's a girl is 11 out of 20. The probability that it's the left-handed child is 1 out of 11. And the probability that the child wears glasses is 4 out of 13. Find the probability that the child selected at random is a boy. So the probability of it being a girl plus the probability of it being a boy is equal to 1. So that means the probability of it being a boy is equal to 1 minus the probability of it being a girl. We know that the girl probability is that fraction. So the probability of it being a boy is 1 minus 11 out of 20. And we know that this 1 is actually 20 out of 20, right? So the probability of it being a boy is going to be 9 out of 20. That is question A. Question B, what is the probability of it being a right-handed child? The probability of it being right-handed is equal to 1 minus the probability of it being left-handed. So we are now going to say left-handed is 1. Probability of right-handed, is equal to 1 minus 1 over 11. So that is probability of right-handed is going to be 10 out of 11. And the last question, what is the probability that the child does not wear glasses? Question C, not 3. Question C. Probability of no glasses is equal to 1 minus the probability of glasses. So that is 1 minus 4 over 13. So probability of no glasses is equal to 9/13. Okay, so this is one way of calculating probability. If they're giving you one probability and they're asking you for the probability of the opposite binary chances of happening. Theoretical and relative probability. So, theoretical probability happens when we are looking at the probability of something happening when you know the chances of something. I don't know. There's this assumption. We assume that all outcomes are equally likely, meaning that if I roll a dice, if I roll a 6-sided dice, the chances of getting 1, 2, 3, 4, 5, or 6 are all equal chances. This is important. So theoretical probability happens when we assume that everything is equally possible of happening. If I am tossing a coin, the chances of it happening is heads or tail, equal probability of that happening. Okay, theoretical probability can happen with a loaded dice, but not at this stage of our learning. Relative or experimental probability occurs when you are looking at a historical fact. So, what this means is, if I ask you, toss a coin, what do you think is the probability of you getting heads or tails? You will probably saying the probability of heads is going to be 1 out of 2, because heads is one option and the heads and tails are the 2 possible choices. If I gave you data and I said I tossed a coin 1,000 times, and when I did that, I got heads, let's say I got heads 68 times out of 100. Okay, so not 1,000, 100. What is the probability of me getting tails? That could be a relative probability question. So that means the probability of getting heads is actually 68 out of 100, which is different, because if I convert this to a percent, this is 50%, and if I convert this to a percent, this is 68%. Notice that these two are different, and that's the whole point I'm trying to get across to you. The reason why they are different is because theoretical probability speaks of what could happen. Relative or experimental probability is based on past events. So yes, it's what could happen, but it's based on what has already happened. So I could ask you, what's the probability of it snowing in July in South Africa? So you are going to look at how many times has it snowed in the past and calculate the probability based on historical data and not based on the chances of it happening without historical data. The last thing I want you to see on the slide is this equation. So when we calculate probability, it's the same for theoretical and for relative, where we're saying the probability of an event called E happening is going to be the favorable option over the possible option, the total possible, meaning that a favorable answer is the answer that you want. It is everything that is in the options for E. So how many choices do you have in E? When it comes to the probability of heads, I have one choice. It's only heads. Then my denominator is going to be all the possible answers. So what are the chances of me getting, what are the choices that I have? My choices are heads and tails, meaning I have 2 choices of that happening. Therefore, probability of an event happening is known as the number of options in the event. For favorable options, or that I get a positive result, it must match this E at the bottom, divided by the number of options in the sample size. Now the sample size is all the possible answers. Over here my sample is 2. Over here my sample is 6. So the SN here, sorry, NS, because I have 6 options in the sample size. Okay. Here is a probability question that says that 6 children are playing chess regularly. The number of games that each child has won is in the table. Timothy won 4 games and lost 10. Andrew won 7, lost 3. Daniela, continue. Now, question A is saying, use the data to find the probability of each child winning a match. How do we do this? We are saying that the probability of a win is equal to the number of options or chances for the win to happen over the number of chances for the total sample size. That is the equation we're going to use, which means if I look at the table, this is going to be my number of options for the win, because it says that's how many times they have won. Next up, I need to know the sample size. Is lost the entire sample size? No, that it isn't. So for us to get the sample size, I need to know the total number of games. That is going to be my number of options in the total sample size. So in this instance, 4 plus 10 gives me 14. 7 and 3 gives me 10. Then we've got 12, we've got 20, we've got 18 and 18. Once I've got this, I can answer question A and I can say the probability for Timothy winning is 4 out of 14. Now I'm going to simplify that by halving it. It becomes 2 out of 7. Probability of Andrew winning, this gives me a decimal of 0.29 or 29% chance of that happening. The probability of Andrew winning is going to be 7, that's winning, over 10, that is total. That gives me a decimal of 0.7 or a percentage of 70% chance of winning. The probability of Daniela winning, 3 over 12, which simplifies to 1 over 4, and it's a decimal of 0.25 and a percentage of 25%. Rachel is going to be 4 over 20. That simplifies 1 over 5, which is 0.2 as a decimal, or 20% as a percentage. Charles is going to be a probability of 6 out of 18, which becomes 1 over 3, and that's 0.333 recurring, or 33.3%. And lastly, Maria is going to be 12 out of 18. That is 2 out of 3, or 0.666 recurring, or 67%. We can round it off to 67% chance of it happening. So over here, the thing that I want to point out here is, yes, we did fractions, and notice that our denominators for the fractions, once the fractions are simplified, are not always the same. We've got a base of 7, 10, 4, 5, 3, and 3. It's difficult to compare fractions with different denominators. Therefore, we either convert them to decimals, which makes it easier to convert, or compare, and percentages also makes it pretty easy to compare. Question number B is asking who's the best player. Now remember, this is the probability of winning, meaning that the best player over here is going to be Andrew, because he has got a 70% or 0.7%, 0.7 decimal of winning. Next up, who is the worst player? The worst player has got the lowest winning score. That is going to be Rachel, because Rachel wins 20% of the time. Next question, if Charles played against Timothy, who do you think would win? So we're saying that probability for Charles is So Charles is 33% and Timothy is 29%. Who is more likely to win? The answer is going to be Charles, because Charles has a higher probability of winning. In a lucky dip at the school, a tub has got 50 prizes inside of it. There are 20 Super Balls, 10 pens, 10 toy cars, and 10 packets of sweets. What is the probability that the first person winning in the lucky dip will get a Super Ball? So let's figure this out. Chances of getting a Super Ball, we said the probability of getting a Super Ball is going to be equal to the number of okay, so this is, I don't know, okay, the number of times you get a Super Ball, or the number of possible options for the Super Ball, let's say SB, over the number of total options. So this means there are 20 options for the Super Bowl and there are 50 possibilities. This simplifies to 2 over 5, which ends up being 40%, or as a decimal, 0.4 probability of getting a Super Bowl. Next question, what is the probability that you do not win a pen? Okay, so the probability of getting a pen is going to be equal to 10 pens out of 50 options, right? Or 1 over 5. The probability of not getting a pen, remember we said probability of no pen is going to be 1 minus the probability of a pen. So that's going to be 1 minus 1 over 5, and that's going to be 4 over 5. In other words, the probability of getting a pen would be 20% probable, and the probability of not getting a pen is 80% probable. Question number C. What is the probability of getting sweets? So the probability of sweets, again using the equation, is going to be sweets is 10 out of a total of 50. So that brings us to 20%, well, 1 over 5, 0.2 decimal, or 20% probable. Last one, what's the probability that you do not get a car? So the probability of a car is going to be 10 out of 50, which is 1 out of 5. The probability of no car is going to be probability 1 minus the probability of a car, which is 1 minus 1 over 5. So the probability of no car is going to be 4 out of 5, which translates to 80% likely that you will not get a car. If we were to add words to these, we could say that the probability of you getting a Super Bowl is unlikely but close to even, right? 0.4 is close to even. The probability of getting a pen is unlikely, and the probability of not getting a pen is likely. Probability of you getting sweets is unlikely. So the word scale, yeah, it's there. Let's look at the next question. If the first person wins a pen, what is the probability that the second person will also win a pen? Now, the implication of this question is that this 50 for the pool, the total at the bottom is going to change. That 50 is going to change. So, probability of getting a pen now becomes, because the pens have now reduced, it's no longer 10 options, it's now 9 pens, and the total number of prizes is now no longer 50, it is 49. So your probability changes to 9 over 49. As a simplified fraction, that's as simple as it gets. As a decimal, it becomes 0.18. And then as a percentage, it's about 18% chance of you getting a pen. Remember over here, initially the probability of getting a pen was 20%, but if 1 pen is removed, your probability changes to 18%. I need to emphasize that both the numerator and the denominator changes, because it's no longer the first person we're looking at. We are now looking at the second person, so the totals have changed. The next question is saying, what is the probability that a person does not win a toy car? The second person. So the probability of a car, remember we're looking at the second person. If it's the second person, it means there's only 49 choices left. But because it's the second person, there are still 10 cars available, because the first prize that was taken out was a pen. So it ends up being 10 over 49 is the probability of getting a car. The probability of not getting a car is 1 minus the probability of getting a car, which is 1 minus 10 over 49. And that gives us 39 over 49, which translates to 0.7959 as a decimal, or approximately 80%, if we do rounding off. So approximately 80% chance of you getting a car or not getting a car, which is the same as this one. Can you see that? So probability of not getting a car dropped by such a small decimal that when it rounds off to the same number. Last one is asking me, what is the probability of you getting a packet of sweets if you are winner number 2? So the probability of getting sweets is going to be, there are 10 packets of sweets left out of 49 prizes left. So that means that we are sitting with 10 over 49, and that is a decimal of 0.204, and that then translates to a percentage of 20% chance of you getting sweets. Let's do one more question. You are going to try and play this spin the pointer game. You win the prize on which the pointer stops. Richard has 1 spin. Which prize is Richard's most likely going to win? So let's start out by seeing what are our options. Okay, mint. I've got 1, 2, 3, 4, 5, 6, 7, 8. Mint features 8 times, meaning that the number of options for mint, the number of favorable options for mint, is equal to 8. Next up, we have toffee. 1, 2, 3. The number of favorite options for toffee is equal to 3. And lastly, a pen. Pen is 1 option. The number of options for a pen is equal to 1. Which begs the question, what is our total sample size? The number of options for our total sample size means I'm going to add all of this up, and that gives me a total of 12. I've got 12 possibilities happening here. Let's answer question number A. A is asking, what is most likely? Obviously, most likely is going to be a mint, because it is 8 out of 12. Mint is most likely. Next question, explain your answer to part A. So if I had to do it numerically, I would say the probability of mint happening would be 8 out of 12. The probability of toffee happening would be 3 out of 12, and the probability of a pen happening would be 1 out of 12. So those would simplify to 0.6 recurring as a decimal. 3 over 12 is 0.25 as a decimal, and 1 out of 12 is 0.083 recurring as a decimal. So 666 recurring. Therefore, the probability of getting a mint is 60% most likely to happen, versus toffee 25%, and a mint happening at 0.8, so that's 8% chance of that happening. All right, question number C says Donna has one spin. Make a copy of the line that you see below and write the probability that Donna would win a pen. So we've said the probability of a pen is going to be 1 out of 12, which is over there. 0.08 translates to, when I multiply it by 100, it translates to 8% probability of it happening, right? We want to do a fraction. Because our fraction is over 12, I'm going to change this instead of it being 1 over 12, I'm going to make 1 over 2, I'm going to make it 6 over 12. So 1 over 12 is going to be somewhere over there, assuming that I have 5 equally spaced numbers over there. So probability for Donna getting a pen is over there. On the line, mark with a W the probability, oh, they said mark with a P for Donna's for the pen. Okay. Mark with a W the probability of Donna winning a watch. And again, this one is relatively straightforward. Watch is not an option. This is not an option. Therefore, the probability of getting a watch is going to be 0. It is impossible. Okay, thank you for watching. I hope that you understood. Be sure to send any questions that you have, and I'll see you next time. Please like and subscribe. Bye-bye.